The tropical rainforests of South America are the stage for one of the most extraordinary dramas in the world of insects. Within these dense forests, we find a species of ant gifted with a natural talent for agriculture, an ability that is nothing short of astonishing. These ants have been practicing farming for over 55 million years, far longer than humans, who only began farming around 12,000 years ago. Surprising as it may sound, this is the truth. These ants understand how to prepare soil, cultivate crops, manage grass and fertilizer, and even defend their farms from pests. They are known as leafcutter ants. They are subterranean farmers, architects, and guardians of a micro-civilization that has existed for millions of years. Beneath the silent and dense canopy of the rainforest, these ants march in neat lines, each carrying a leaf fragment several times larger than their own bodies. Despite their small size, they can collectively cut and carry as much leaf matter as an adult cow consumes. A single colony can move more than 500 kilograms, over 1,100 pounds, of leaves per year. The tale of the leafcutter ant begins with the power of their jaws. With sharp mandibles resembling surgical scissors, they cut leaves with astonishing precision. Leaf by leaf, the pieces fall not by wind, but by the effort of insects just a few millimeters in size, equipped with a remarkable natural mechanical ability. Unlike most ants that consume food directly, these ants do not eat the leaves they cut. To them, the leaves are merely raw material for something far more important, something that takes place beneath the Earth's surface. Once a leaf is cut, the job isn't over. It must be transported back to the nest. And this is when the magnificent parade becomes truly visible. Hundreds, even thousands of ants form a long procession, each carrying a green fragment above its head. This activity resembles a bustling city highway, crowded, noisy, but constantly moving. These leafcutter highways are well organized, with inbound lanes for ants returning from the trees and outbound lanes for those heading into battle against the foliage. The leaves, often much larger than the ants themselves, are carried with skill and balance over roots, loose soil, and tiny obstacles. They do not give up under the burden. They are trained from birth because this is their destiny. Underground, the leaf fragments are transformed into fungus gardens. Once inside the nest, the leaves are cut into smaller pieces by gardener ants, then chewed and mashed into a green pulp. This pulp is layered in the fungus garden like compost, from which tiny white fungi grow. These fungi are the main food source for the colony, especially the larvae and the queen. What's truly amazing is that this fungus does not exist in the wild. It has co-evolved to live only with the ants. If separated from them, it dies. This relationship is called obligate symbiosis, a biological partnership where both organisms cannot survive without each other. The ants take care of their fungus just like farmers tend to their fields. They remove rotten fungus, apply enzymes and body fluids, and even use natural antibiotics produced by their own bodies to kill parasitic fungi. Yes, leafcutter ants use antibiotics to protect their crops from pests. This natural defense mechanism has even inspired modern medical research. The nest of a leafcutter ant is like an underground city inhabited by millions of individuals. They dig tunnels as deep as 6 meters, about 20 feet, and create a network of hundreds of chambers, each designated for fungi, eggs, larvae, or waste. Amazingly, each ant knows its role without being ordered around. This is the power of intelligent decentralization. There is no military commander or central authority. These ants aren't driven by a single mind, but by millions of synchronized instincts. Inside the nest, conditions are crowded, humid, and buzzing with activity day and night. Without proper sanitation, catastrophe could strike at any moment. But leafcutter ants are masters of cleanliness. In their microscopic world, hygiene is not just about comfort, it's about survival. The fungus they grow is highly sensitive. A single contamination from a parasite fungus like Escovopsis can destroy an entire garden. That's why worker ants called minims have a special role to clean everything, every leaf fragment, every larva, every tunnel, even the bodies of other ants. They lick the leaves with antiseptic fluid from their bodies. If a leaf is deemed unclean, it is discarded far from the garden. There are even special cleaning ants that remove corpses, waste, and foreign objects. They create waste dumps at the edge of the nest, functioning as microscopic landfills. More impressively, some leafcutter ants carry actinobacteria on their bodies like a protective cloak. These bacteria produce antibiotic compounds that prevent harmful fungi from growing. This is a form of natural biotechnology, older than penicillin. Leafcutter ants have an extraordinarily complex social structure. A single colony can contain millions of individuals, up to 8 million. But don't imagine chaos. This is a highly organized society. Every ant knows its role. At the heart of this massive operation lies the queen, deep underground. She is not just the mother, but the symbol of the colony's continuity. She is much larger than the workers and has only one task: to lay eggs, up to 30,000 per day. The queen never leaves the nest after mating. She is the central production hub for new ants, workers, soldiers, and even future queens. She also preserves the original fungus strain, passed down through generations. Protecting the queen is as important as guarding their food. Without her, there is no regeneration. Without her, the kingdom collapses. The leafcutter colony operates under a caste system determined by age, size, and biological function. Minims, the smallest ants responsible for caring for eggs, larvae, and the fungus. They rarely leave the nest and are sensitive to changes in temperature and humidity. And Dryamedias, medium-sized worker ants that cut and transport leaves. They work tirelessly throughout the day. Majors, large-bodied ants with massive heads and strong mandibles. They protect the lines, confront predators, and clear blockages. Foragers, scouts who search for new sources of leaves. They don't carry leaves but map out safe, fertile roots. Gatekeepers, guardians of the nest entrance, ensuring no intruders or pathogens enter. All roles are carried out systematically without spoken orders. This phenomenon is known as collective intelligence, where simple individual behaviors form a complex, effective social system. In human society, we communicate through speech, writing, and gestures. But in the world of leafcutter ants, scent is the language. They communicate using pheromones, chemical signals released by their bodies and interpreted by others in the colony. A tiny drop of pheromone can convey messages like food ahead, enemy approaching, danger here, or follow me. When a scout finds a tree rich with leaves, it marks the path with a pheromone trail. Soon, hundreds of workers follow that trail, cutting and carrying leaves from the same tree in a synchronized green convoy. Pheromones also regulate traffic. When paths become congested or dangerous, ants reroute, and that information spreads quickly, without a sound, just a scent. This chemical communication system is so efficient that computer scientists once used it to develop search algorithms for navigation and logistics systems. Despite their seemingly flawless system, life isn't easy for leafcutter ants. Every journey beyond the nest is a risk. In the jungle, predators lurk everywhere. One of their deadliest enemies is the phorid fly, a tiny but lethal parasite. These flies land on the backs of worker ants and inject eggs into their bodies. When the eggs hatch, the larvae eat the ant's brain from within. The ant becomes disoriented, wanders aimlessly, and dies a slow death. To defend against this, soldiers stand guard along the trails, and workers carry minim passengers on their backs. These minims repel parasitic flies before they can strike. But flies are not the only danger. Predatory ants, spiders, insect-eating birds, and even humans threaten their survival. Still, the colony endures. Day by day, leaf by leaf, they rebuild their future. Leafcutter ants know when to expand. As a colony grows and the nest becomes overcrowded, they begin forming new branches. This is usually initiated by a new queen. The process is dramatic. A young queen takes flight, mating mid-air with a swarm of males. Once mated, she finds a new location, digs into the earth, and plants a small sample of fungus from her original nest in her mouth, a seed for the next generation. From one queen and a handful of fungus, a new colony begins, and the cycle of life continues once more.